the next thing that we're looking at is the intersection and union of sets. The intersection of sets A and B, which we show with this symbol, this means A intersects B, is the set of elements that are in A and B. Okay? The symbol is an upside down U, and we can think of it as looking like an A so that we can remember that this means and. Okay? So it has to be an A and B for it to be the intersection of sets A and B. The union of the sets A and B we show with this U, so we can think of that as union. Union is the set of all elements in A or B. Okay, so if it's in either one, we would include it in the union of the sets. So, for example, it wants us to find A intersects B. Okay, which we just said meant that it had to be in both. So A intersects B, and remember we talked about if we're talking about the sets that we have to show the braces. So we're looking, whenever we're talking about the intersection, we're looking for numbers that are in both. So in A we have 4, 8, 12, and 16. In B, we have 5, 8, 11, 14, and 17. So the number, or numbers, the elements, that are in both is just 8 in this case. So we write 8. Now, for a union B, that means we're going to put those two sets together. So again, we're going to use our braces. And we have to include everything from both. So we have 4, 5, 8, which we're just going to write once, 11, 12, 14, 16, and 17. This would be the union of sets A and B. I want you to go ahead and try B on your own, so go ahead and pause the video at this point, please, and you need to find the intersection and the union of sets A and B. To find the intersection of A and B, okay, that's again where we're talking about the elements that are in both. So in A we have 1, 3, 5, 7, 9, and in B we have 2, 4, 6, and 8. Well, A is all odd numbers, and B is all even numbers. So obviously there aren't going to be any that are in both, because those are opposite types of numbers. Well, opposite is not the word I should say, but these are odds and these are evens. So whenever we have this, we have a null set or an empty set, and we can show that by showing our braces with nothing inside, or that circle with a slash through it. Now if we're talking about A union B, we have to include all numbers in both sets. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. This would be A union B. A set of numbers has a closure under a given operation if the outcome of the operation on any two members of the set is also in the set. This is something that in middle school usually confuses students, so I hope that we can get a better handle on it at this time. What this is saying is that it has closure under a given operation. Our operations are addition, subtraction, multiplication, and division. If the outcome of the operation on any two members of the set is also in the set. So, for example, if I take any two positive numbers and I add them, or any two counting numbers, and I add them, is my answer always going to be a counting number? So if I take my counting numbers 1, 2, 3, 4, 5, 6, etc., and I add any two of those we'll say 1 and 17. 1 plus 17 is 18. That is also a counting number, so we would say that the counting numbers are closed under addition. So, for example, want to know true or false, the set of integers is closed under addition. So if I take any two integers and I add them, am I always going to get an integer? So let's think about that. My integers are all the numbers that I would show on a number line. So if I had a number line, we'll go ahead and we'll show 0 in the middle. We have 1, 2, 3, 4 on this side, and -1, -2, -3, -4 on this side. If I add any two of these numbers, am I always going to get an integer? Well, let's think about this. If I take -3 plus 4, -3 plus 4 gives me 1. 1 is also an integer. If I take -4 plus 4, that's going to give me 0. 0 is also an integer. So we'll say that this is true. The next question, true or false? The set of natural numbers is closed under subtraction. Natural numbers are our counting numbers. So our counting numbers, we will say, include 1, 2, 3, 4, 5, and it keeps going, right? So I'm talking about subtraction. So let's say I take, we'll go with 5 minus 2. Well, 5 minus 2 is 3. 3 is a counting number, or a natural number. But what if I take 2 minus 5? Well, 2 minus 5 is going to give me -3. So is -3 a counting number or a natural number? The answer to that is no. So we are going to say that that is false. And that's it for lesson 1.